Hey, Algebra 2. We are moving right along in Unit 2. We're going to do a little more with writing equations of lines. Okay, we talked about slope last week and the fact that every line has a steepness associated to it, and that's the slope of the line. Okay, if my line has a positive slope, we call it rising from left to right. If we have a negative slope, it falls from left to right. If it has a zero slope, then it's a horizontal line. And if it is an undefined slope, then it's a vertical line. Okay, those are the types of slopes we talked about last time. We also noticed that when two lines are parallel, they have the exact same slope. Okay, for example, these two lines would both have the same slope. They have different y-intercepts. They have different points associated with them, but their steepness is the same. If two lines are perpendicular, then they have opposite reciprocal slopes. Okay, one's positive, one's negative. That's the opposite part. And then if this, for example, if this slope is 2, then this slope is a half, negative a half. Okay, they're opposites and they're reciprocals. All right, that was last week. Little recap. Okay, and you did a Schoology assignment. You participated in a discussion, and we're moving forward now to actually graph lines once we're given the equation of a line. Okay, this every line. This is something called slope-intercept form. If it's in this form, we talked about this last week as well, then the slope is always the number in front of x. So this slope will be 5 over 2. The y-intercept is always this number, which makes sense, right? Because the y-intercept is what we get when we put 0 in for x. 5 halves times 0 is 0. 0 plus 10 is 10. Okay, it's actually an ordered pair. I don't care if you write y-intercept equals 10 or if you write it as an ordered pair 0, 10, either way. Now the x-intercept, unfortunately, we can't see right off the line. Okay, I can't see the x-intercept. The x-intercept is what we get when we put 0 in for y. Then that'll tell us where our line is crossing the x-axis. So I have to solve a little equation. 0 equals 5 halves x plus 10. Okay, that's how I find the x-intercept. I have to substitute 0 for y. The notes are right over here for you, a little cheat sheet, okay? So to solve this equation, I would subtract 10 from both sides and get negative 10 equals 5 halves x. To get rid of multiplying by 5 halves, I divide by 5 halves. Okay? Or dividing by 5 halves is the same as multiplying by 2/5. So I really could think of this as negative 10 times 2/5. I like to multiply instead of divide by a fraction. That gives me negative 20 over 5. Guys, when you multiply a number times a fraction, you multiply straight across the top. Negative 10 times 2 is negative 20. 1 times 5 is 5. The answer to this is negative 4. Okay, so the x-intercept is negative 4. All right, so we're going to put x-intercept, negative 4, comma, 0. Okay, hopefully you still have your work there on your notes. I'm erasing mine, so it looks a little neater. Okay, we put 0 in for y. That's what it tells us to do here to find the x-intercept, substitute 0 for y, and we got negative 4, 0. Okay, if I have those things, I can graph this line. Okay, my x-intercept is negative 4, 0, right here. My y-intercept, I didn't give you enough room, it's 0, 10. Oh well, I can use my slope to get to another point. My slope is rise over run. We talked about this last week. So from this point that's on my line that I know, I can go up 5 and over 2. Or I can go down 5 and to the left 2, because negative divided by a negative is still a positive slope. Okay, that's going to go through at, if I could extend this, you can see that the y-intercept would be 0, 10. This is what every single point on this line works in this equation. Okay, what do we get here? We got the point -2, 5. Isn't that what this point is that we found? We're saying that when y is 5, then I can take 5/2 times the x coordinate of -2 plus 10. This will be a true equation. I'm putting -2 in for x, 5 in for y. 5/2 times -2 is -10/2, or -5. -5 plus 10, yeah, that's 5. Okay, you'll get a true equation with every single point. Every single point on this line works in this equation. That's why we say here is a picture. A line is a picture of all the solutions to this equation. Okay? Anyway, so we can graph any line, especially if it's in slope-intercept form. If it's in slope-intercept form like this, y equals, this is the slope, this is the y-intercept. To find the x-intercept, we have to put 0 in for y. Okay? Whoops, sorry. All right. Let's look at a different form. Okay? This is something called standard form. I don't see anything here, guys. Okay? I don't see the slope. The slope's not 5. It's not in the right form. Okay? This is a nice way to find the x-intercepts. If I'm in standard form, sometimes this is how I find the x and y intercepts. I make a little xy chart. I put 0 in for y. 6 times 0 is 0. So that gives me 5x equals 15. So that would mean that x would be 3. When y is 0, x is 3. Then I erase that and I put 0 in for x. Boom. 5 times 0 is 0, right? So now I have 6y equals 15. Okay, because this part's 0. 6y equals 15. Divide by 6, divide by 6. Y equals, looks like 2.5. Right? 15 divided by 6. If I divide each of those by 3, I get 5/2, which is 2.5. So I know my x-intercept is 3, 0. I know my y-intercept is 0, 2.5. I could just go ahead and, as soon as I have the x and y-intercept, I can go like so and graph, like, as soon as I have 2 points, I can graph it. Looks like I'm going to have a negative slope, doesn't it? Not sure what that slope is. There's a couple ways I can find out. I can, now that I have these points, I can subtract the y's. 2.5 minus 0 divided by what I get when I subtract the x's. So that's 2.5 divided by 3. If you do that on your calculator, 2.5 divided by 3, it gives you 5/6. Okay, so I'm saying it looks like you go down 5, 1, 2, 3, 4, 5, over 6, 1, 2, 3, 4, 5, 6, and that'll be another point on the graph. Okay, up 5, 1, 2, 3, 4, 5, to the left 6, 1, 2, 3, 4, 5. Yeah, okay, it looks pretty good since I was kind of sloppy. 5/6 is the slope. If you don't want to subtract, you can take your equation and rewrite it so that it's in slope-intercept form. Go ahead and subtract 5x to the other side. Okay, I'm subtracting 5x over with the 15. That gives me a 6y equals negative 5x plus 15. Now I'll divide everything by 6. Negative 5/6x plus 15/6. Okay, which we already saw is 2.5. So I have y equals, let me write that better, y equals negative 5/6x plus 2.5. Then I can see, oh, the y-intercept's 2.5. I already graphed that. The slope's negative 5/6. That makes sense. Okay, there's multiple ways to do this. This little hint over here is if you do have something in standard form, I don't really memorize these. It's too many letters to memorize. I memorize the process. If I want the x-intercept, I put 0 in for y and solve. If I want the y-intercept, I put 0 in for x and solve. They're saying the x-intercept will always end up being this number divided by the number in front of x, 15/5. The y-intercept always ends up being this divided by the number in front of y, okay? 15/5 was 3. Yeah, that was the x-intercept. 15/6 was 2.5. That was the y-intercept. They're just giving you a little shortcut since these terms zero out. You don't have to memorize these, okay? The slope is always the opposite of a over b. So the opposite, it would be the opposite of 5/6, which is what we got by using our math. The math will always get you there if you understand how you're doing it. I prefer that to memorizing these, but it's okay. To graph, you either plot the intercepts or you can use the slope, either way, or a combination. Okay? Example 3. What if you have a bunch of these other forms? Okay, this doesn't look like standard or slope-intercept, right? This is just a disaster. I do not know what kind of form this is. So we just do our algebra until we find the form. I know I can distribute and get 6x plus 10. I could subtract 10. I get 6x equals negative 3y. I'd like to get y by itself. So I have y equals negative 2x. Okay, maybe I'll write it this way. Y equals negative 2x. If I think about it, that's negative 2x plus 0 if I want to be, really precise about the formula, okay? The y-intercept is 0 then. I can see it. Now that it's in my slope-intercept form, I see my y-intercept is 0. I see my slope is negative 2. My x-intercept, well, I'll have to put 0 in for y. Ooh, it looks like the x-intercept is 0, 0 as well. Okay, with my slope of negative 2, I might write that as a fraction and go down 2 and over 1, down 2 and over 1, or I'll go up 2 and to the left 1, as long as I make one negative move. Okay, and then I can graph that. The x and y intercepts were the same, weren't they? They were both 0. Okay, and my slope was negative 2, my y-intercept was 0, my x-intercept was 0. And I used my slope to go down 2 and to the right 1 to find my other points. Okay? Vertical and horizontal lines are supposed to be the easiest. They end up being the hardest. People just don't like these things. Okay, if you just have x equals, like for example this one, I'm going to distribute my 2 through. I'm going to add 2x to this side, giving me 5x. I'm going to add 2 to the 8, giving me 10. I end up with x equals 2. Well, that doesn't look like any of the forms we've had. What this means is the x coordinate is always 2. 2, 0, 2, 1, 2, 2, 2, 3, 2, negative 1. You end up getting this vertical line. Okay? The slope of a vertical line, as we saw last time, is undefined. Similarly, with this one, I get 2y is negative 6, y is negative 3. That means the y coordinate is always negative 3. 1, negative 3, 2, negative 3, 10, negative 3, whatever. I get this horizontal line. Sorry, you can draw a better one. I'm running out of time. So horizontal line, the slope is 0. Okay? And here's a little hint on, all the different ways to graph, etc. All right, good luck with the homework, and I'll see you in class.